Okay, here we are, back again for the next part of the power supply project. And what I'm going to do tonight is, I say tonight because it is 1:30 in the morning, and it's about the right time to do making things. So what I'm going to do is I'm actually going to fit the big pass transistors on the heatsink today. Now, this particular heatsink is able to take the transistors either side, but as we're going to be mounting this surface to the back panel, you want the wiring on the inside, so the transistors will effectively go in like this. So you'd effectively have them in like that, and for four of them, so they'd all sit together. But you can't just put them in like this, unfortunately, because there are several issues with that. Not least of all is you have to make sure that they're the right way round, which actually makes it that they go this way round on the heatsink, because as you see, the slot is nearer one end than the other, so they would actually go this way round. You also have to insulate these from the heatsink itself. Well, that's strictly not true. You could connect these directly to the heatsink without any insulation spacers or anything like that at all, and then what you'd have to do is you'd have to insulate the heatsink from the chassis that you're connecting it to, because effectively then this is at the unregulated DC voltage of the transistors, because on these transistors the whole case is actually the collector of the transistor. As you probably know, most transistors have, let's grab that one, 3 leads, and whether they're wired collector base emitter or emitter base collector, whichever way round, you have 3 leads, but these only have the 2 pins, and that's because the collector is actually the whole of this metal case. So what you have to do is choose one way or the other. Now, I personally prefer having the heatsink isolated from the case, and the reason for that then being that you can mount this straight onto a metal case, and then the heat transfer, if it builds up on here, will pass through to the metal it's mounted on, adding extra capacity to the heatsink. So you're generally far better off having the heatsink isolated from the DC voltage if you can. So the technique that you have to use involves, let's move that one back out the way and out of shot, using these mica washers, and also it involves using heatsink compound to aid the thermal transfer, because what you're effectively doing is you're putting a non-conductive layer between the metal and the metal, so that the heat doesn't flow as well. So you're basically trying to dissipate as much heat directly into the metal as possible. So the way to do that is, first of all, you get your highly toxic to wildlife, nasty toxic gunk, and you squirt a bit onto the back of the transistor, like so, and then you fit the mica washer like that, and just goop it all around, and as you see, that then spreads out and covers the back. You then smear a little bit more straight down the middle of that, like so. I'll just put the lid on so that It doesn't go everywhere, because it does go everywhere if you let it. And then you take the transistor and you can either offer it to the heatsink or have the heatsink offered to it. Now I tend to find that first of all I'm going to look to make sure I've got the transistor the right way up. Yep, it's that way. I'm then going to put that with the pin through the hole like so, and then that gunks neatly in there. So then you've now got to fix it down so that it can't move and it can't go anywhere. And what I tend to do is I use these screws here. Now these particular ones are longer than what I'd normally use, but they're what I've got to hand. So they would go in like that, but you can't just drop them straight in, because what are you going to do? You've got metal to metal, you've just broken your insulation. So you've got to, again, two ways of doing it. You can either insulate from the outside or insulate from the inside, and I find you can just drop that straight in, but then what you have to do from the back, you put the insulating washer there, so you've got a plastic insulation so that the body of the screw can't touch the heatsink. You then put an ordinary washer on top, and then, because you want to connect everything together, you screw that down there like that, and make that tight. Now what I'm going to do is I'm not going to tighten them all completely until I'm ready to mount them properly, because you still need to actually spread the heatsink compound, and you also have to make sure that you get these pins so that neither of them touch the heatsink. So you get another one of those, you can put that in through the back, and that will fit in the center of the hole, or it should do, assuming that your insulating mica is in the right position. And you can get another screw and put it in, and again make sure that the sides of the screw aren't touching the base. Now, because you're actually going to need to make an electrical connection, you're going to need to put a tab on. Now then you'd put your washer on, and then you'd put your nut on the end of that, and again you tighten that up, and that's the first one pretty much done. Now at this point you can decide exactly what position you're going to put all of these tabs, and I tend to bend them up like that and have them run through in a line like that, because then all of the ones that line up and all of the pins that line up will be able to connect together with a single straight piece of wire, so you're not jumping wires all over the place. Now, as I say, you just have to make sure you've got enough wiggle room that nothing there is touching and nothing else is touching the heatsink. Now, in theory, again, I should use smaller tags, but these are what I've got. These are, I think they're the old 2BA size tags, which is an ancient British measurement of size. And all I'm going to do now is I'm just going to tighten up that one. Just going to make sure that stays in a straight line. And tighten up that one. And just to make triply sure, I'm going to get the meter, set it to continuity test, and I'm going to make sure that those two should be contacted. Yeah, but the case and the aluminium is not. Now you should get a reading there of some resistance because you're going collector emitter, I believe, collector base, and then if you do emitter base, there you are. So we know that's a working transistor now as well, but we also know that it's not going to touch anything at all, so that's ready for complete tightening and putting the next one on. So I'll put the next 3 on and then we'll go on to the wiring. No point in you sitting there watching me put all 3 in, or all 4 in, I can't count myself, and we'll see you back in a few minutes. Stand by and we'll be back. Bye for now. Right, okay, now we're back. Let me just make sure you're in focus. Yep, there we go. As you see, all of them are there. The heatsink compound has squished out nicely from both sides. Word of warning, I did say it was toxic. Before you eat anything, before you go and touch your pets, before you do anything, wash your hands. You don't want to kill off your fish or injure your guinea pigs or your mice or your hamsters or make your dog sick or anything like that. So anyway, back to electronics. That's really the strange part about this. These particular transistors have the G marking at the end of the number, 3771 Gs. That signifies they're lead free because of environmental reasons, but you stick them down with highly toxic heatsink compound. Okay, not really makes any difference to the environment, does it? But hey, that's legislation for you. So out of the irony of legislation, what we've got now is we've got to connect all of the bases together, all of the collectors together, and we have to solder a resistor to each emitter and then connect all the emitters together. So what I'm going to do, ordinary mains flex is perfectly adequate for this. If you want, you can use tin copper wire, or this is actually tin copper wire. You can probably just about see the copper underneath, but I've had this for years. You could use, this heavy duty stuff if you really wanted to. Could use a bit of coat hanger, and as long as you can solder it on, it's completely up to you. What a lot of people will say is, oh, you need really heavy wires for carrying that huge amount of current. Well, you've got a very thin piece of wire there. It's thicker than most components, but that piece of wire is designed to carry the full rated current. So is there any reason to go up to coat hanger or above? Some would say yes, some would say no. Yes, admittedly, the thicker the wire, the less of a volt drop, but yeah. It's focusing again. Was that because my head moved? That seemed very strange. So anyway, and the way I'm going to do this, I'm just going to strip the insulation off this bit of wire, and hopefully it will come off cleanly. If not, I'm going to have to do it in small sections, and just that's because it's rubber coated, isn't it? It's not going to behave itself because this is pond wire, not standard electrical flex. There we go. So let's get the, yeah, see I've already split some of the conductors there. We shall have to go further down. So once you've got it started, let's get those bits off, you should be able to just peel a section away like so, and then just peel the whole lot down the length of the cable. And what I'm going to do is I'm going to twist with the wire to make it into a single strand. So let's just keep peeling and keep twisting in the same direction. And like so. Come on, off you come, last little bit. There we go. Right, so, and the last bit, there we are. Like that. Right, so now you have a piece of wire which can then thread through. I think it can thread through, I haven't actually measured it, but I should be able to thread through the holes in these tabs. Yeah, if I actually get the end nice and tight. Oh, you say you're going to do something and then something will always jump up and bite you in the ghoulies. It's like threading a needle. See, there's another whisker. See, that whisker could be quite nasty. What I could do actually, just to make it a touch easier, is I could just hopefully, let's see if I've got it just enough to seal the end. Come on. Trouble with a piece of wire this big is you're going to need a fair amount of heat, so I can feel it travelling up my fingers already. So yeah, so that's warm, but that should now fit without any issue at all through there, through there. Let's just aim that through there and then through there. And don't forget, we still have to keep it isolated from the case, so from the heatsink. But I am going to put a turn in the end like that. The good old J hook of past. And then all you do is clean the tip of your soldering iron and solder these on. There we go. Heat the tag up, and then the solder should melt around that and the wire. Now the last one, as you notice, is back to front, and that's because I want to keep it within the heatsink area rather than have it splayed out this end, just for neatness sake really. Okay, so that's that. Now if we do the bases of the wire, let me just get rid of all that rubbish, and because you're just tagging on the side of this, do I do this? Do I do it with this piece of wire? Can do. What I'm going to do is I am going to tin that one, and I'm going to see if I can get enough heat into this wire. That's, again, as I say, this, see, with this thick wire, trying to get enough heat in to actually get the solder to take is quite difficult. So catching on the box of screws, so let's just take that one and come on, melt together. Go. Once we've got the first one in, we can then do another one. Just put some heat on there, put some heat on there, and then the two should take. Just hold them together like so. Do that one there. There we go. And then the final one. And for this, yes, I'm going to use the pliers. I'm just going to pull that in. You see there's a lot of spring in this wire. There we go. Let's just heat the two together. Just hold it in place. So there we have all of the bases connected, and you can see that they're not touching any of these screws. And before you say, oh, there needs to be more separation, don't forget we are dealing with DC here. We're dealing with very low voltage DC. I say very low voltage, 30 volts DC comes under low voltage, so not exactly a risk of arcing across. Now all we've got to do is the emitters. So with those, rather than have great big floppy just take them down so that they're that high. They don't need to be right to the end. And again, if you just tin the emitter, might as well tin them all. Okay, and then tin the resistor. Now these are 0.2 ohm resistors. They're nothing really exciting or flash or unusual. They're a standard component. And again, let's just tin that. See if I can do it on camera so that you can see. There we go. And again, tin that like that, and that will float. Just hold it in place until it cools. Yep. Let's do one at a time. So heat the pin. There's the resistor. No, that's moved, so that would have made a dry joint. And the final one. And there we go. We now have the regulation pass transistors wired up. All we have to do now is connect these to the power supply board, and we then have to work out which one of these. I'll have to look up the data on this transistor. Let me see, I've got my laptop open in front of me, and have I looked it up? No, that's the previous one. There we go. Right, pin 1 is the base, pin 2 is the collector, and pin 3 is the emitter. So emitters, pin 3, collectors on pin 2, and the base on pin 1. So all we have to do to connect those is do one to there, those 4 to the middle, no, those 4 to the end, and collector on pin 2. So that one's in the middle, that one's on this end. Right, so yeah, I think I know what I'm doing now. So what I'm going to do is I'm going to just chop off that loose end there, because we don't quite need that there. I'm also going to chop that off there, because we don't need to use bare wire for that. And I'm going to just put a loop there, so that I can bend it round, make a nice easy terminal to loop a bit of wire into, like that. So let's choose a colour. So brown for base, I think brown will be good enough for base. So let's just loop that one through there, like so. And just solder all that together. What I'm trying to do is I'm trying to get the solder to flow, but again, this thick, huge wire is sucking all of the heat away from the joint. There we go. Might as well use that for the bases. Sorry, for the collectors, because I've just done the base. So all I'm going to do with this is I'm going to add that. There's the laptop fan kicking in, saying, I'm getting hot, I'm getting hot. I'm just going to hook that round there, like so. I could have left half the wire covered in the insulation and left it as it was, but yeah, in this case I didn't. Let's just solder that in there like that. As you see, this is taking the solder a lot more easily. Okay, and now we've just got to do that. Now, to make it a different colour, what have we got hanging around? That's what I'll do. I shall join them there, and I shall join those there, like so. So that we have 2 and 2. I shall use this to go between there and there, like so. And I shall use some, I really shouldn't use black because that would indicate neutral and it's actually the output live, so let's use some white wire. Don't need it that long, depends where I mount the circuit board in the thing, so I'll make it as long as the other two bits of wire. Says 7 maximum load 200 watts, 17 amps single. Okay. And again, that will connect. Come on, you. Straighten out. It's been on that. Okay, there's me not watching the time again. So we missed the connecting of the white wire to the bottom of the board because it was too thick to go through the hole. So really that is now complete and ready to power up. So there we go, that's ready to put power onto it. So it's AC 24 volts there, DC out. I think the next part of the video will be the initial test of this as a power supply, and then we'll go on to mounting things into the metal box and seeing how it behaves. I'm still not sure that I'm going to use this as the final regulator circuit. I'm still toying with the 723 idea and going along those lines, so it's a case of watch this space. But anyway, thank you for watching, and hopefully I shall see you again very soon. Thanks very much. Bye bye.